Hello, this is Mr. Feeney, and I'm sorry I'm just now getting this video to you. I hope this video will help you a little bit. If you've been doing your work, it should be able to fill in some gaps for you. And see how I miss you? I filled in 10 milliliters of tears. I do miss you. We're going to get started today right away. I have to make a very short video here. What you've been doing is called the mole concept and factor label. We did factor label first semester, but you just had to remind yourself how to do it. First of all, look on the periodic table, and you'll notice that elements, for example, here's carbon and here's hydrogen. We already know what the other number is, a number of protons. That's the atomic number, but we're going to look at the decimal numbers this time. The decimal numbers have to do with how much they weigh compared to each other. So if you look at hydrogen, it has a weight of about 1, and carbon about a weight of 12. So it's about 12 times heavier. So if you look in the tiny world, here's what you find out. That little number means one atom. If I could only see one atom and I could weigh it, it would weigh about 1.008 atomic mass units. And the carbon would weigh about 12 atomic mass units, about 12 times heavier. Now here's where it comes in. Scientists needed to know how many atoms of one element were combining with another, but we couldn't do it. Why not? They were too small. They were too small, and there were just too many to count. So what happened is they started with this idea. It's kind of like a dozen, except it's bigger than a dozen. What if I had a dozen hydrogen atoms? It would be 12 times 1, or 12 AMUs, and a dozen carbons would be 12 times 12, 144. It'd still be 12 times heavier. So as long as you give me the same number of atoms of each one, then I can compare them. So they came up with an idea. Which one of these has more mass? A dozen carbon atoms? Which one has more mass? A dozen carbon atoms has more mass than that. But do they have anything in common? This one's heavier. What if I had a dozen cars and a dozen grains of sand? They wouldn't weigh the same, but they would have something in common. It'd be the number. And that's what the mole is. The mole is a number. It's Avogadro's number of particles. So 1 mole of hydrogen atoms is more than 12. It's going to be 6.02 times 10 to the 23rd. And if you give me that many atoms, now all those atoms now weigh 1.008 grams. Now I can do experiments with grams. So that's how the mole idea is going to help us. What about carbon? 1 mole of carbon is also equal to not 12 like a dozen, but Avogadro's number, 6.02 times 10 to the 23rd, and instead of being 1 atom is 12.01 AMUs, give me this many atoms and it's 12.01 grams. And a paper clip's about a gram, so I can see 12 grams of carbon. I can do experiments with that. Now, what we're going to do is we're going to make equivalents. Equivalents are how we're going to get into factor label. Let's look at the next page. Look at this right here. And this is how you're going to do your worksheet. And then also we have an open book, something open note, open book quiz tomorrow, okay? On Friday. So let's take a look here. Notice that for any element, 1 mole of that element equals so many atoms. And again, a dozen would be 12, but a mole is not 12. A mole is always 6.02 times 10 to the 23rd. That's a lot of them. Atoms. So let's go ahead and pick an element on the periodic table. Let's go with beryllium. Beryllium, right there. 1 mole of beryllium equals 6.02 times 10 to the 23rd atoms of beryllium equals, now this is the only thing you need the periodic table for, right there, 9.01 grams. And that's how you get your equivalents. This equals this equals this. Now, let's do another one. 1 mole, and we'll pick another element. Let's go with helium. Here's helium. 1 mole helium would equal, again, a mole of anything is this many. It's a large number, a huge number. 6.02 times 10 to the 23rd, and if it's an element, you put the word atoms after it. But how do we get the mass again? This is called the molar mass, how many grams it takes to make a mole. The molar mass of helium, I look over here in this little decimal number, 4 grams of helium. So it's almost like mole, atom, gram, mag, M-A-G, M-A-G. Now, what about for compounds? Now, compounds are where elements are combined. And in this case, let's take a real common compound like, like water. Now, we're doing compounds that have nonmetal. It's a covalent compound. This is a nonmetal and a nonmetal. 1 mole of water equals, well, you don't have to ask. A mole of anything is this many pieces, but there's no such thing as an atom of water. See, it's not on the periodic table. So the smallest piece of water is called a molecule. Molecule of water. See, that's the only difference. The only difference is I don't put atoms. I put atoms if it's an element. I put molecules if it's a compound of a nonmetal. And how do we find the mass? Same thing. We have 2 hydrogens. Each hydrogen's 1. So you have 1 plus 1, and each oxygen is 16. So the total mass is 18. 18 grams of water equals 1 mole of water. Again, this is called the molar mass. Let's do one more. This is a diatomic element, but it's really 2 oxygens combined together as a compound. 1 mole of oxygen gas equals, again, it's always this number, but the smallest piece of this is still a molecule because it's a compound. Okay, and how do we find the mass again? Well, each oxygen is 16. I have 2 of them. 16 plus 16 is 32. So the molar mass is 32. It takes 32 grams of O2 to make a mole. Now let's go to the problem. This is how you're going to do your worksheet. The first problem is 8,200 grams of iron, and they want to change it. If you look on here, they say, can you change that to moles? Calculate the number of moles. All right, now watch. Before I start the problem, I'm going to write my 3 equivalents for iron. It's an element, so 1 mole of iron equals 6.02 times 10 to the 23rd atoms of iron equals, look on the periodic table again, 55.8 grams, MAG, okay? Now, we're only going to use 2 of these 3 equivalents. Which one do you use? Well, what label has to go away here? Grams of iron, okay? And what the chart says is they want you to calculate the number of moles. So I want to get rid of grams of iron and replace it with moles of iron. So I go down here and look for them. Ready? Where's grams of iron? No, it's not grams. No. Yes, there it is. That's why I put 55.8 right there. And what else I'm looking for? Moles of iron. That didn't say moles. That didn't say moles. That does. Oh, 1? That's all you put? Yeah. So in the calculator, this is on the top. So it's this divided by that, and you should get 146.95. And what's the only label that's not canceled out? Moles. Moles of iron. That's how you do that problem right there. Now we're going to skip down all the way down to number 8. Here's problem number 8. Number 8 says, calculate the mass. Mass is grams, okay? So this is my given. They give me molecules, but they want me to change it into grams. Okay, so let's take a look here. What do you know about F2? F2 is actually a compound. It's 2 F's bonded together. 1 mole of F2 equals 6.02 times 10 to the 23rd molecules of F2. It's a compound again. Equals, well, each fluorine is about 19. 19 plus 19 equals 38. So now I have my 3 equivalents. I'm ready to go. All right, what label has to go away? Molecules of F2. And what do you want to change it into? The problem says calculate the mass. So I'm going to change it into grams of F2. Now I go find them. Grams of F2. There it is. 38. And what am I going to go down here? Molecules, see? 6.02 times 10 to the 23rd. Now, when you put this in the calculator, you have to be really careful because when you have a scientific number in the denominator, you have to use parentheses. So you're going to have 8.39 times 10 to the 23rd, and you have to use this key right here. When you get to the top of the exponent, you have to go over there, and they have to know the exponent's done there. Times 38 and then divide it and then put parentheses here, right here. And then you should be able to get 52.96 grams. Okay, anyway, that's how you do those problems. I hope it helps. You can use any of the notes I give you, anything you want for the open note quiz tomorrow. Okay, thank you very much.